Good afternoon, ladies and gentlemen, and welcome to your video lesson for today. We are going to be talking about graphing exponential functions. We have been talking about exponential functions a little bit. We talked about last class how the exponential function formula was f of x is equal to a times b to the x, where a we talked about how it was connected to possibly the first term when we talk about geometric sequences, but it's not exactly the same. And we talked about how b was the common ratio, right? And so the warm-up today is asking you to write an exponential equation based on two sequential, meaning they come in order, two sequential points. And we talked about that last class. What I would like to do is go through number one and show you an example of number one, and then have you repeat that process for number two. So you're really only going to be doing one of these on your own. Again, as with any video lesson that we do in here, please pause the video when you need to. If I ask for the video to be paused, please go ahead and pause it. Those are directions for the sub there. But in any event, here we go, working with our exponential equation, representing the following points here. So what we can do is look at this and say, all right, well, I have sequential points. My x value, 4 and 5, they come right after each other. And what we talked about last class is what we can do is divide the y values in order to find out what my b value is. So to calculate the b value, what we're going to do is divide each of the y values, right? So the b value is this in our function, and we're going to divide the y values in order to find what the common ratio is. Remember, the common ratio is what we're always multiplying by, and so we're dividing to find out what it is. So I'm going to take 8,192. I'm going to divide it by 2,048, and that gives me an answer of 4. So my common ratio is 4. I'm halfway to being able to write my equation at this point. Now I have to find my a value. One of the ways that we can find our a value is by substituting in a point that we already know. So I'm going to use this point. Okay, so this is getting kind of messy here. Let me start over with my marks. This is going to be my x value that I use. That's my y value that I use. Remember, y and f of x mean the same thing, so I'll be substituting 2048 in for f of x. And 4 is the x value that I'll be substituting in. I already know what b is, so I will be solving for a. So this is what that substitution looks like. It's then 2048 is equal to a, which I don't know I'm trying to solve for, times 4, which is the b value that I just got, to the x value, which we're going to use 4 for the x value as well. And now I start solving this for a. Well, 4 to the 4th power is 64. So I get 2048 is equal to a times 64. And when I divide both sides by 64, I end up with an a value. On this left-hand side, I end up with 8. And over here, I get a. Okay? So I don't need two equal signs here. So 8 is equal to a. And now I can write my exponential function. So f of x is equal to that a value that I just found, which is 8, times the b value, which I found earlier, to the x power. So this is my exponential function. So go ahead, pause the video. I would like you guys to try number 2 on your own. So go ahead and pause the video and work on that on your own. All right, hopefully you had some time to work on that. I did make one slight error. 4 to the 4th power isn't 64, it's 256. So when I took 2048 and divided by 256, that's how I got my 8. Not divided by 64, that would have been 16 instead of 8. So let's go ahead and look at this one. You guys were asked to write the exponential function here. To find your b value, you should be taking 18 divided by 54, and you see me doing that here. The fraction answer is 1/3. If you put 0.3 repeating, you might run into problems because you're going to end up rounding that number and your a value won't be as accurate. So keep it as a fraction of 1/3. Then to find a, I'm using this term right here, -2/18, and I'm substituting the -18, the 18 in for f of x and the -2 in for x. 1/3 to the -2 gives me 9. So I get 18 is equal to a times 9, divide both sides by 9, and I get my a value of 2. And now I have everything that I need to write my exponential function. F of x is equal to 2 times 1/3 to the x power. Okay, so that was our warm-up. Let's get into our graphing portion for today. So let's go back to this. All right, so 15.4 is the lesson out of your online textbook. We're talking about graphing exponential functions. We're only going to look at 4 graphs today. And we're going to look at this thing called like end behavior in some of them. And that refers to like what happens when I go, so here's my graph maybe, and I go ahead and I graph. We've already kind of noticed some of this, that some of the exponential functions look like this, right? So like what happens as I go really, really far in that direction? Okay, so this function I might say goes to positive infinity. What happens if I go really, really negative? Well, we would say that it gets closer and closer to 0. So we're going to look at specifically those things. And we're also going to see how in the world, if I wanted to, how can I get this graph to end up not in these quadrants, but these quadrants. All right, I realize this kind of looks like a mess right now, but that's where we're heading with today's stuff. So here is a function that we're going to graph and observe. So the way that I'm going to do this is I'm going to have you guys have the video be paused. I want you to graph the 4 points that are given to you, and then I want you to fill in what is your a value, what is your b value, you should be able to pick that out, and what is your y-intercept. And then I'm going to come back after the video has been played again, right? So you guys are going to work on this, you're going to fill in the table, you're going to fill in your graph, after you're done with that, the video can be played again, we look at the answers, and we'll discuss these end behavior questions and some of the patterns that we notice. So go ahead and pause the video right now and work on filling out your table, and then from your table, go ahead and fill out the graph. All right, hopefully you've had some time to fill out your table and create your graph. If we look at the table here, all I'm doing is taking -1 and substituting that in for x, right? So 2 to the -1st power times 2 will give me 1. Anything to the 0 power, so 2 to the 0 power, if I substitute that in for x is 1, 1 times 2 is 2. If I substitute in 1, I get 4. If I substitute in 2, I get 8. Things to notice here. When we enter in at our a value being 0, right, when our x value is 0, we talked earlier about how that could be a y-intercept, right? So anytime we have equation that crosses the y-axis, we have a y-intercept, and anytime we have a y-intercept, that x value is always 0, and we get some number, right? We talked about last class how that number appears in the equation here as our a value. So our y-intercept ends up being 0, 2, and that comes from this particular 2 right there. So without even looking at the table, you should have been able to notice that, oh yeah, my y-intercept is going to be 0 because it's going to be a y-intercept, and my x value is always 0 for a y-intercept, and my a value is 2, so it substitutes in for a y. Again, my b value here, my common multiplier, or constant multiplier, or constant ratio is always 2 for this one. And the table is as follows. When you look at the graph looks like this. And here's how we interpret these questions about end behavior. Okay, so end behavior. What happens on either end of the function? So as x approaches infinity, so this is positive infinity, what that means is as x goes in this direction that way, right? What happens to the function? What happens to y? Well, if we look at the graph, what happens to y? Doesn't it get a lot bigger? That is true. So as x approaches positive infinity, so does y. It gets to positive infinity as well. Now we're asking the opposite question. What happens when x is approaching that direction. What happens really, really far down this way, right? When is x negative infinity? Well, when x is negative infinity, what happens to this function? It approaches 0, and we did some investigation about that last class. So as x approaches negative infinity, as the graph heads in that direction, it doesn't go negative, right? It goes closer and closer to 0. We talked about that last class. Domain, remember domain are your x values, range are your y values. So are there any restrictions for our domain here? If we look at our domain, our x values, we already talked about how it can go from negative infinity to positive infinity. So that means our domain is equal to all real numbers. Anything. Our domain can be anything. And when our domain is the all real number set, where are our possible y values? Did we have any y values down here? The answer to that is no, right? The closest that we got was really close to 0, but it didn't even touch 0, right? So our range, or our y values, are always greater than a certain amount. What number did it get really close to? It got really close to 0. So our range is y is greater than 0 for that particular graph. So a couple things to notice. The original equation. B value, that was greater than 1. And we got a graph that went up. We would expect that. My A value is 2. That's my y-intercept right here. We notice that. And when that was positive here, and this was greater than 1, all of our values were in quadrants 1 and quadrant 2. Okay. Next question. We're going to do the same exact process, except for we have some different values. Notice my B value is now between 0 and 1. We talked about what happens then. So go ahead and fill out your table. Go ahead and fill out your graph. And after you're done with that, the video can be played again. And go ahead, and we'll talk about the answers to end behavior and domain and range for this particular one. All right, ladies and gentlemen, hopefully you've had some time to go ahead and fill in your table, answer your questions, and graph it. And so let's go ahead and talk about these. Table values are as shown. Hopefully you're able to get those. We've had lots of practice with calculators to be able to use those and find the values. My A value, remember, is right here, so that's 1. And my B value is right here, and so that is 1/3. That is my constant ratio. The y-intercept, you can get it from the graph, or, again, we talked about how the A value is the same as what we get for our y, the y-intercept. So our y-intercept is 0, 1. We also notice that on the graph. Okay. In general, guys, the y-intercept is always going to be, for an exponential function, 0, a. Okay? And whatever that a value ends up being is what your value is there. Okay. So let's talk about end behavior for this one. So same questions. As x approaches positive infinity, so as we head this direction, what does the graph do? Well, last graph went up like that, right? So we said it approached positive infinity. But that's not what happens this time. This time, it heads closer and closer to 0. So as x approaches positive infinity, we get y getting closer and closer to 0. And let's head in the opposite direction. What happens as x approaches negative infinity? So as the graph heads this direction, what does the y value do? Well, again, in the last graph, if we look at it, in the last graph, as we headed this direction, it got closer and closer to 0. This time, the graph is going the opposite direction, and it's heading up and up and up. Okay? That means it approaches positive infinity. Okay? If we look, everything as we go in the negative direction is being multiplied by 3. 1 times 3 is 3. 3 times 3 is 9. The next value at negative 3 would be positive 27, and on from there. So it approaches positive infinity in the negative direction. All right, my domain, again, there are no restrictions for my x value, right? We talked about x going from infinity to negative infinity. So my domain, again, is all real numbers. make that a bracket, I suppose. Oops. And my range, well, what is my range? What are my y values, right? These are my possible y values. So the lowest y value, again, is that 0, okay? It never actually gets to 0, but it gets really close to 0. My highest y value, well, we said y goes to positive infinity, right? So my range is y is greater than, put this in brackets again, y is greater than 0. All right? So notice, again, in this particular graph, my b value here was 1/3. It's between 0 and 1, so we got our declining graph, right? It goes down, but it never got negative. It got close to 0, and we head in the opposite direction. My y values get really close to infinity. So that's why my domain is all real numbers. It can go any direction, left and right. My x values can be anything, but my y values have to be greater than 0. Okay? Close my brackets there. All right, so now let's look at number 3. This graph is going to be quite a bit different than the last one. It's still going to have a curve to it, but this little difference right here, that -1, okay? Notice the last graph was a +1. This one has a -1. You will get a different looking graph for this, okay? So go ahead, same exact process. Go ahead and fill out your table. Go ahead and fill out your graph, and then we'll talk about your answers when you're done with that and we play the video again. Okay, hopefully you had enough time to complete your table and your graph. Let's go ahead and talk about our values. So take a look. These are the table values you should have gotten: -1/3, -1, -3, -9. Notice that every value here is negative. That comes from the fact that we are multiplying by a negative value. Our a value is negative, so everything that comes out of this ends up being negative. Okay, my b value is 3. A value is -1. Those things we should have picked out. So my common ratio is 3. And what we get for our y-intercept, remember, is that 0, 0, comma a. And my a value is -1, so this is my y-intercept, 0, -1. And again, we can see that on the graph right here. Okay, so looking at the graph, this one looks slightly different than the last one. If we flip back and forth between the last graph and this one, we have, let's look at the first graph, I suppose. This one had growth in the positive direction. This one had decay, or it went down in the positive direction, all right? And that comes from the fact that we have a negative a value. So let's talk about end behavior. What happens as we go really far out in each graph? All right, so as x approaches positive infinity, so as x heads this direction, right, what kind of values do we get? What happens to the graph? Well, it's declining. We get less values that are more and more negative, right? So y is going to which direction? What value? It's not getting closer to any specific number. It's just getting more and more negative, which means we are heading to negative infinity. As we head in the negative x direction, what happens? Well, our y values never get positive, but they get really, really close to 0, just like the other ones get close to 0. All right, so what does that mean for my domain? Again, my x values can be anything, right? I can go left and right, and it works for the function. There's nothing that x can't be, so we have all real numbers. My range, what can my y values be? Well, I didn't have anything up here, right? And before, if we look at the last two graphs, my range always was up here, right? I had nothing down here before. In the first graph, my range was all up here, and I had nothing down there. So we have kind of the opposite effect, and again, it's due to that -1 value. So what are my range values? What do I have? I don't have any positive range values at all. We can tell that from the table, right? They're all negative. So that means my range is now not greater than 0 like it was before. They're all less than 0. Again, not equal to 0 because it never actually touches 0. But they get really, really close to it in the negative direction, and they get really, really negative in the positive direction. So everything is less than 0 for the range. And again, it's because A is negative. All right. So last graph for the day. So go ahead, fill out the table, work on the graph. You guys know the drill. All right, last graph of the day. Hopefully we still have some energy left to talk about this one. All right, so a couple things to notice. Again, in this equation, we have a negative A value, and our A value is -2. B value, my common ratio, is 0.5. And again, we can find from our A value where our y-intercept is. My y-intercept is 0, -2. Again, we can see that in the table, and it finds itself in the graph. Okay, so graph looks like so. So let's talk about the graph. As I'm heading in the positive x direction, heading this way, what happens? Does the x value get really, really positive? Or the y value? Does the y value get really, really positive? No. It heads up, but it only approaches 0 again. Okay? What happens as x heads in the negative direction? Well, it goes more and more negative, right? And in fact, there is no limit to the amount of negative that we have, right? It keeps going. So if we look at our constant ratio, it's by 0.5. But as we head in this direction in the table, what we're really doing is kind of multiplying by 2 to go the other direction, right? So from -2, I'm multiplying by 2 to get -4. From -4, I'm multiplying by 2 to get -8. The next one will be -16, -32, -64, and so forth. So it's going to get more and more negative. So let's talk about end behavior now, right? So as x approaches positive infinity, so as we're heading this way on the graph, what happens? It gets closer and closer to 0. So y approaches 0. As x goes to negative infinity, so now we're heading this direction, what did we say? It gets more and more negative, and so it goes to negative infinity. There is no end to where it will end up going in that direction. There's no limit to it. All right, so then what does that mean for my domain? Again, there's no restriction on what my x values can be. So my x values are, again, all real numbers. And my y values, well, let's look at what we got. Let's go erase some of this stuff here. Again, where is the graph? My y values are anything this direction, right? Here or here. Well, I have nothing above the x-axis, right? All of my values are in quadrants 3 and quadrant 4. So everything is below 0, and that's what we save for my range. My range is now, again, less than 0. So my y values can only be negative, and it shows in the table, and it shows in the graph for this particular function. And again, the reason being is that my a value is negative. I have negative a value. So let's look at some summary for this here. What I would like you to do is to take a couple minutes on your own, maybe 5 minutes or so. So pause the video for maybe about 5 minutes, and I want you to try to answer these questions on your own, and then play the video again, and I will discuss the answers to these. Okay, so hopefully you've had some time to go over these questions. If not, that's okay. We're going to wrap it up right now anyhow. So it says, look back at the 4 graphs, and as x approaches positive infinity, some of the graphs had y approaching 0. What do you notice about the b value? Well, let's be real clear about what we're talking about. As some of the graphs had, as x approached positive infinity, some of the graphs had y approaching 0. So which graphs had y approaching 0? Well, if I'm approaching 0 as I go in this direction, That means in the other direction, I must have been very high or very negative with my y values. So we're talking about these two kinds of graphs. A graph that looks like this, or a graph that looks like this. And it says, what do you notice about the b value for these? So let's specifically go back. Let's look for a graph that looks like the two that I just drew. Right? So if we look at this one, then this kind of looks like garbage. I'll clean this up. This was our original graph for that, right? And what do we notice about our b value? Well, our b value was 0.5. That is in between 1 and 0. So we're approaching 0 when the b value is in between 1 and 0 in that particular graph. Let's see if it's true for the other one that was like that. Again, I'll probably have to clean it up a little bit. So I'll erase some of this stuff so we can look at the original graph. And as we look at this one, oh, I get rid of the graph. Well, the graph, undo. You can undo that. Sweet. All right. So back to this. Okay. So there's the graph. And what was my b value here? Well, the b value, again, was in between 0 and 1. And we talked about this a little bit last time. B is less than 1, but also greater than 0. When that b value is in between 0 and 1, we get our value. We talked last class, because everything was positive. We talked last class, is it getting smaller, right? But really what we're doing is we're approaching 0, but now from two different directions. Okay? So if we answer this question, what do we notice about the b value for a graph that looks like this? And what that means is that y approaches 0 as x gets positive. We notice that b is less than 1, but at the same time greater than 0. So between 0 and 1. Okay. So let's look at the next part. As x approaches positive infinity again, some of the graphs had y go now in the opposite direction. Instead of to 0, they went really, really big. They went to infinity. What do you notice about the b value for these? So what graphs are we talking about here? So as we're heading in this direction, our y values got closer to positive infinity. So we're talking about graphs that look like this, or yes, just a graph that looked like this. So as we go back to that, what kind of graph produced, what kind of b value produced a graph that looked like this? Well, again, I'm going to have to clean something up. That would be this one here. So clean this up. Get this stuff. Okay, so that's what our graph looked like. It approached, y approached positive infinity. What's our b value here? It's positive 2. So what was our b value? It is greater than 1, right? Now, we had one other incidence of a b value that was greater than 1, right? But if we look at the graph for this, and again, I'll clean it up. If we look at the graph for this one, it approaches negative infinity, right? We talked about that. So for this particular question, as x approaches positive infinity, some of the graphs had y go to positive infinity. What do you notice about the b value? The b value was bigger than 1, right? However, if our graph approaches negative infinity, our b value is also greater than 1, right? So in order to get our values, or our graphs, to go close to 0, our b value is in between 0 and 1. In order to get our graphs to go to positive infinity or negative infinity, our b values have to be greater than 1. Awesome. All right, next question. And I'm going to get rid of this shade now for a second. Da-da-da. All right. What graphs were in quadrants 1 and 2, and what graphs are only in quadrants 3 and 4? What do you notice about their a values? And we talked a lot about this already, but quadrants 1 and 2. If you're not familiar with quadrants, remember quadrants are labeled this way: 1, 2, 3, almost drew number 3, and 4, right? And so in terms of the relationship to the x-axis, we have positive y values are above the next x-axis, or negative y values or below the x-axis, right? So how did those a values shake out? What did we have for an a value when we have the graphs in quadrant 1 and 2 up here? Well, let's go back and look at those graphs. So this one had the graph in quadrant 1 and quadrant 2. And what was my a value? A value was positive, positive 1. So a was positive for this particular graph. If we look back at the first graph, again, we're in quadrant 1 and quadrant 2. And what's my a value? Again, my a value is positive. So what's the pattern here? In order to get a graph in quadrants 1 and 2, in order to get a graph in quadrants 1 and 2, a has to be positive. Okay? Now, how do you think we get a graph to be in quadrant 3 and 4? Remember, now we're talking about down here. Well, let's look at those two graphs. This one, we had a graph, and our y values were in quadrants 3 and 4. And what was our a value? A value was negative, right? All right, maybe write this one. Okay, because we have a negative 2a value here. And in the other graph, we had an a value of negative 1 here. And did that result in a graph that gave me y values in quadrants 3 and 4? Yes, it did. So, in general, how do we get our graph to be in quadrants 3 and 4? How do we get y values in quadrants 3 and 4? We have to have a negative a value. Okay. And the last question, I think we beat this pretty well. When an exponential function of the form f of x equals a times b to the x is graphed, what does a represent? What does the a value represent? The a value, remember, represents the y-intercept. And our y-intercept for these equations will always be in the form of 0, comma, whatever the a value is. Okay? Awesome. Well, that's been your video lesson today. This is posted on Schoology, so if there's parts where this went too fast, you can always go back to Schoology and watch this anytime you want. Your independent practice for today is, these are the page numbers, but we're in 15.4. You'll find this lesson, or these homework problems, in 15.4. You don't care about page numbers because you have an online textbook. And you can do problems 5 through 12, number 21, and number 25. I hope you guys have an awesome day, awesome weekend. Take care. Peace.